Second lesson, we will talk about the difference between the scalar and the vector. Scalar and the vector, as we studied in Part 3, will differ, and the scalar has a magnitude only, while the vector has a magnitude and direction. As an example, if I cover the length of 10 meters, and I said I cover a length of 10 meters without any other details, so I give you the magnitude only. If I tell you that I cover a length of 10 meters toward the right, toward the left, toward forward, toward backward, upward, downward, then I give you the value and I give you the direction. So I'm talking about a vector quantity. Scalar quantity has a magnitude only, vector quantity has a magnitude plus direction. As an example, if I tell you that I cover a length 10 meters, so I tell you the distance, which give the magnitude only. But if I tell you that I have covered a distance or a length of 10 meters toward the right, so I tell you the displacement. Another example is the difference between the mass and the weight. Mass is the scalar quantity which giving you the number of kilograms of our bodies or any other quantity in kilograms. But weight is giving you the direction of our body is toward downward, is toward the earth, which we have the weight which is we will know it in our curriculum as the force for the gravity. Speed, the difference between the speed and the velocity is the same. Speed I have covered 10 meters per second without any detail on the direction for its speed. But if I told you that I have covered 10 meters per second toward the right, toward the left, so I tell you the velocity. Another way to detect the vectors is differing between two vectors at the same time. If I have a node, this is a node, two persons are pushing the node in the same direction. The first one are pushing the node by 500 and the second one are pushing this person is pushing the node by 200 newton. The resultant of the pushing will be 700. So if I push a node by two vectors in the same direction, the resultant by the summation of the first vector and the second vector. If two persons apply a work on a node by 7 joules and 5 joules in opposite direction, if I'm talking about the resultant will be 2 joules toward the meter. 7 joules is greater than 5. So if I'm talking about an opposite direction, the vector summation will be by subtraction. If the angle between the two forces, is 90 degrees. Assuming that I have a load, this load is attached by a tension wire toward the x-axis and another tension wire toward the y-axis, which are perpendicular to each other. The load will not move neither to the x nor to the y. It will move in between them by making an angle θ1 and θ2, θ1 between the resultant and the x-axis direction, θ2 between the resultant and the y-axis direction. Mathematically, by making an extension here with the resultant, it becomes a diagonal, which can be replaced by another diagonal. They are equal distance, they are having the same properties. So we can replace this resultant by making fx, fy, which they are perpendicular to each other, and replacing the resultant with another one to be satisfying the rule of Pythagoras. So I can make a rule between fx falls in the x-axis, fy falls in the y-axis, and f resultant. By using Pythagoras rule that we have studied in Part 3, the curriculum of mass, f resultant squared, which is indicate the hypotenuse, will equate with the side x squared submitted with the side y squared. Or there is another way, which by using the angles between the resultant and the x-axis, or the resultant and the y-axis, it's called the angles way. The angles way by using θ1 or θ2. Θ1 has 3 factors. sine the theta, cosine the theta, tan the theta. Sine the theta, we have studied that sine theta is opposite of the theta to the hypotenuse, while the cosine is the adjacent of the theta to the hypotenuse, when the tan is opposite of the theta to the adjacent. So if I'm talking about the sine theta, we have to know that sine theta 1 is the opposite, which is Fy to the hypotenuse, which is F resultant. So it's an issue between Fy and F resultant. Cosine the theta adjacent over the hypotenuse, so cosine is the adjacent of the theta 1, which is Fx, to the resultant. Tan theta is the issue between Fy to Fx. Why? As tan theta is opposite to the theta to the adjacent, so Fy to Fx. Replacing the theta 1 by calculating the force due to theta 2. It depends on the given in the problem. In the problem, if theta 2 is given, so sine and cosine and tan theta 2 in such examples, theta 2, sine theta 2 opposite over hypotenuse, theta 2, the opposite is force in the x-axis to the hypotenuse, forces of the resultant. Cosine theta 2 is adjacent to the hypotenuse, adjacent Fy to the hypotenuse F resultant. And tan theta 2 is Fx to Fy. So you have to study this well. At the next session, we will make a worksheet on these rules to know how to solve problems well. Thank you.